2 over x squared minus 3 over x plus 1. Well, to do this subtraction, the fractions need to have the same denominator. So let's rewrite them. 2 over x squared, I'm going to write it as 2 over x squared times x plus 1 over x plus 1. So this is equivalent to that because I've just multiplied the top and the bottom by the same thing. And then I'll put minus, and then this second fraction here will be 3 over x plus 1, and I'll multiply the top and the bottom by x squared. So multiply the top by x squared and multiply the bottom by x squared, and we need the parentheses right there to be clear. Okay, now look, the denominator here is x squared times x plus 1, and over here it's x squared times x plus 1. So my answer will be this minus that all over that denominator. So let's do that. And this right here, this is going to be 2x plus 2. Okay, then minus, and this is obviously going to be 3x squared. And all that will be over x squared times x plus 1. And we're basically done, except I don't like the way this numerator is written right there. It would be pretty standard practice to write a polynomial with the higher power terms first. So I'll write minus 3x squared plus 2x plus 2 all over x squared x plus 1. Okay, here I'm told to simplify this complex fraction, 2 over y plus 1 all over 2 over y plus y over y plus 1. And the technique I'm going to use will be to look at all of these small fractions. That's this one, and this one. And from those three fractions, find the least common denominator. And so you can see a y plus 1, a y, and a y plus 1. So just looking at the denominators, I find a least common denominator of y times y plus 1. Now if I multiply the top and the bottom of this fraction by that, all of the little fractions will disappear. So watch this. I'm going to write this out. Now you might be able to do this step mentally, but I'll go ahead and write it out here. So it's 2 over y plus 1. I'm going to multiply it by y times y plus 1. And then all this was over 2 over y plus y over y plus 1. I'm going to multiply the whole bottom there by y times y plus 1. Okay. Now when I actually do this multiplication, this up top it's pretty easy. This y plus 1 and that y plus 1 cancel out. And so the numerator just becomes 2y. See the 2 there and the y. 2y. Okay, now down below, it's a little bit trickier, but it still cancels out nicely, and it will every single time. Look at this, y times y plus 1 has to be multiplied by this and this. We're distributing. So y plus 1 times that, when we multiply this by that, you should see the y's will cancel out. See that? We're left with 2 times y plus 1. So let's write that. 2 times y plus 1, and then I have this plus sign right there. Plus, okay, next I'm going to multiply this times that. And when I do that, you should see the y plus 1 cancel out, and I'm just left with y squared right there. So now notice I no longer have a complex fraction. And this works every time. Finding the least common denominator of all of these little fractions within your big fraction, multiplying the top and the bottom by that, will always cancel out all of those denominators. And we're left with a fraction still, but it's not, at least it's not a complex fraction. And here we're basically done. I just want to clean that up a little bit, write it in a more standard form. So I'll write 2y, and down here this is 2y plus 2 plus y squared, and let's write it like this, y squared plus 2y plus 2. Standard polynomial form with the higher power terms first. And we're done.